automated, open-ended scientific discovery, explores the potential of using large language models, LLMs, to automate the entire scientific research process. What are the key challenges in automating scientific discovery?
Automating scientific discovery is a complex task that involves several challenges. First, it requires the ability to generate novel and interesting research ideas. Second, it needs to design and execute experiments, which can be computationally expensive and require domain expertise. Third, it needs to analyze and interpret the results, which can be subjective and require human judgment. Finally, it needs to communicate the findings in a clear and concise manner, which often involves writing scientific papers.
This paper proposes a framework called the AI Scientist to address these challenges. Can you explain how this framework works?
The AI Scientist framework leverages LLMs to perform all stages of the scientific research process, from idea generation to paper writing. It starts with a simple initial code base and a broad research direction. The LLM then generates novel research ideas, designs experiments, executes them, analyzes the results, and writes a full scientific paper. The framework also includes an automated reviewer that evaluates the generated papers.
That's quite a comprehensive approach. Can you elaborate on the idea generation process?
The AI Scientist uses LLMs to generate novel research ideas by iteratively growing an archive of ideas. The LLM is prompted to generate new ideas based on the existing archive, taking into account the novelty, interestingness, and feasibility of previous ideas. The LLM also uses chain of thought prompting and self-reflection to refine and develop each idea.
How does the framework ensure that the generated ideas are novel?
The AI Scientist uses the Semantic Scholar API to search for related papers and discard any ideas that are too similar to existing literature. This helps to ensure that the generated ideas are novel and contribute to the field.
Once an idea is generated, how does the framework design and execute experiments?
The AI Scientist uses a state-of-the-art coding assistant called Aider to implement the proposed experiments. Aider takes the initial code base and the proposed changes and generates the necessary code. The framework then executes the experiments and collects the results.
How does the framework handle errors during experiment execution?
Aider is designed to handle errors during experiment execution. If an experiment fails or times out, Aider attempts to fix the code and rerun the experiment up to 4 times. This helps to ensure that the experiments are completed successfully.
After the experiments are completed, how does the framework analyze and interpret the results?
The AI Scientist uses Aider to analyze and interpret the results. Aider generates a set of notes that describe the results and any interesting observations. It also creates visualizations of the results, such as plots and tables.
How does the framework write a scientific paper?
The AI Scientist uses Aider to write a full scientific paper in LaTeX format. Aider takes the notes and visualizations generated from the experiments and uses them to fill in a template for a standard machine learning conference paper. The framework also uses the Semantic Scholar API to find relevant references and automatically generate a bibliography.
That's impressive. How does the framework evaluate the generated papers?
The AI Scientist uses an automated reviewer based on GPT-4o to evaluate the generated papers. The reviewer takes the paper as input and generates a review that includes numerical scores, strengths, weaknesses, and a preliminary decision, accept or reject.
How does the automated reviewer compare to human reviewers?
The automated reviewer achieves near human-level performance on various evaluation metrics, including balanced accuracy, F1 score, and AUC. It also shows a lower false negative rate than human reviewers, meaning it is less likely to reject high-quality papers.
That's interesting. What are the limitations of the AI Scientist framework?
The AI Scientist framework has several limitations. First, the generated papers are often of medium quality and may contain errors or inaccuracies. Second, The framework is currently limited to machine learning research and may not be applicable to other scientific domains. Third, the framework relies heavily on LLMs, which are still under development and may not be able to handle all aspects of scientific research.
What are the ethical considerations of using AI to automate scientific discovery?
There are several ethical considerations to consider when using AI to automate scientific discovery. First, it is important to ensure that the AI system is aligned with human values and does not produce harmful or unethical results. Second, it is important to be transparent about the use of AI in scientific research and to ensure that the results are properly attributed. Third, it is important to consider the potential impact of AI on the scientific community and to ensure that it does not displace human researchers.
This was a fascinating discussion on the AI Scientist Framework. Thank you for your insights.